to 210, not one house at the beginning of the street and one house at the end. The main costs increase incrementally between the homes. So we'd like to get the whole block if possible, or in a grouping like that. Any questions?
What if for propane?
Propane is usually an easier conversion for the homeowner. That's something they would need to discuss with their HVAC contractor. Most of the newer propane system, it's an easier conversion to convert to natural gas. There's an orifice that's in the equipment. It's actually what regulates the gas flow. In many cases, that's all that has to be swapped out, is that orifice. Some of the newer oil burners are that way also. Again, you'd need to check with your HVACA contractor. The older oil burners that out there usually cannot be converted to natural gas. They would have to be replaced. Propane's a very good conversion, very simple conversion. Any other questions? I'll be handling the project through until the completion of this main portion. Mike will be coming in afterwards, so if you apply within the next year or so, dealing with me. After that, it would be Mike's office, but all those applications, we all work together, so they would all go together. Thank you.
Next, we have a presentation by Doug Meeker on stormwater management.
As Ed mentioned, this is a part of the Sustainable Communities Program. And this particular portion is an educational piece that will hopefully show people, help them learn about the importance of properly managing stormwater. So why is stormwater management important? The hydrologic cycle describes the movement of water up, on, above, and below the earth, whether it comes down as rain and then some of it soaks into the ground to recharge the groundwater for our water supply. Some of it runs off into streams to support the streams. Some of it evaporates back up into the sky to cycle back through again. So the big question is, what happens to rainwater when an area develops, like when it goes from forest or farmland to buildings and roads and that sort of thing? On the left is a representation of what's referred to as pre-development, or forest or farmland condition. And on the right shows a post-development condition where some houses have been built, or buildings and roads. And in the developed condition, your impervious surfaces, or surfaces that don't allow water to freely move through them, like a street or the roof on your house, divert the runoff from its normal patterns. And what that results in is a decrease in the infiltration of water into the ground to recharge the groundwater, potentially a decrease in the base flow of the streams, and also less evapotranspiration, which is the water evaporating back up into the clouds to be recycled. So the impact of the developing the land is you go from the natural condition on the top left, and as your development density increases, meaning you create more impervious surfaces on the ground, the infiltration of water decreases and the runoff of water increases, because it can't infiltrate into the ground and it can't evaporate like it would naturally do. Traditionally, stormwater has been managed in several ways. Mainly, it's collecting it after it already falls on the ground and diverting it to different devices that will hold the water for a period of time and also filter the water. Thank you. I should have brought my kids with me to help me with this. So some factors that are considered in when evaluating stormwater management is the peak flow rate, and the higher peak flows caused by impervious surfaces mean that more water runs off and you have more frequent and more intense floods potentially. Larger volume of stormwater runoff means more energy that will erode the streams. And if the groundwater is not allowed to recharge because there's too many impervious surfaces, the streams will tend to dry up. And it also leads to poor water quality because there's an increase of contaminants like the oil from the cars, from the streets that are washed off when it rains, pesticides and fertilizers from lawns and gardens that get washed off with the rain. So what happens when we don't manage stormwater properly? One of the most noticeable, immediately noticeable results is flooding. Flooding of streets where there aren't adequate drains to carry the water away, damage to properties, erosion in the streams and the creeks, and also, as I mentioned, the pollution that enters the waterways. This is an oil sheen from a parking lot. So what are we trying to protect by managing storm water? Well, it's our water resources, the water in the streams, the groundwater that we eventually drink. So over the years, there's been a lot of studies and there's been a lot learned about stormwater management. And a few of the goals for managing stormwater include being smart about your development plans and how you lay out developments, where development occurs. And it's ideal to capture and treat stormwater as close to the source as possible. When stormwater first evolved, the school of thought was, well, you collect it all and you pipe it all to one place that may be miles away and then worry about it there. But what that neglected was groundwater recharge and some other very important issues that over the years we found that need to be addressed. We still need to reduce the volume of stormwater to control erosion and attenuate the peak flows to control flooding. And we also filter stormwater to remove pollutants before it's allowed to infiltrate back into the ground or run off into streams. It's also very cost-effective to use and promote methods that provide multiple environmental benefits and reduce the life cycle costs of these stormwater systems, because not only are the systems very expensive to construct, but there is perpetual maintenance that can also be very costly if the system isn't designed properly. So sustainable stormwater management mimics nature by integrating stormwater management into building and site development to reduce the impacts that urbanization has on our natural resources. And some cutting-edge best management practices. One is as simple as increasing topsoil depth. Because if you don't have proper topsoil depth, you can't establish good vegetation. If you don't have good vegetation, not as much water infiltrates into the ground and you get erosion. Infiltration trenches and bioretention systems are natural filters. They're planted with vegetation that has a large uptake of nitrogen, phosphorus, and other pollutants that are washed off with the stormwater. Porous pavement is becoming very popular, and all that is you have a street where traditionally no water was able to infiltrate, and the pavements that they're using now actually allow the water to infiltrate through them. Another new concept is low-impact development. And some of the principles of low-impact development are to cluster buildings together rather than spreading them out over a larger area. Maintain natural drainage patterns, so try to make sure that you're mimicking nature as much as possible and not diverting flow, runoff, stormwater runoff to an area where it didn't go before, potentially reducing flow to a stream that might cause it to dry up. Minimizing impervious areas, maintaining groundwater recharge, and preserving and protecting natural resources. On the left is a kind of a typical example of a subdivision development. There's streets and lots all around the streets. And then on the right-hand side is an example of that same property where low-impact development techniques have been used. And a couple of things that of note are the lots are clustered together. They're smaller and clustered together. The streets are narrower. And what that allows is for large areas of natural vegetation to be preserved and large areas of open space to be preserved as well in the community. And these low-impact development techniques can be used on individual lots. Here's a typical lot where towards the front, out by the street, there's a bioswale, which is just basically a ditch with a kind of a peat mix bottom with plants in it that filters the stormwater. Rain gardens in front of the house, those landscaped areas, which are a different type of bioswale, but still the same principles the same. It's kind of a peat soil mixture with lots of different plants. Infiltration areas which promote infiltration of the rainwater into the ground so that it recharges the groundwater. Pervious decks, pervious walkways that let the rainwater go through them and infiltrate into the ground instead of just running off. Cisterns, rain storage, or more commonly known as rain barrels, that are tied into the downspouts from a building that then you can reuse that water for watering gardens or other things. Retaining natural vegetation is around the back of the lot, and also is key to use native shrubs and native trees because they require less fertilizer, pesticide, and water. And when you get onto more dense development, you can still use these same techniques. And the picture on the right is actually the backyard of a house, and that is a large rain garden that is providing stormwater treatment for the entire house and the patio area around it. And it's been designed and integrated into the backyard of that house, and it's very nice. In the middle is another example of a low-impact development that's that's actually treating some street runoff in a town, and they created a little park, and in the middle of the park are these planted bioretention areas that are providing stormwater management. And that leads us into the next topic, which is green streets and drainage corridors. These convert stormwater from a waste directed into a pipe to a resource that replenishes groundwater supplies, provides attractive green spaces and enhances neighborhood livability, provides natural habitat, and it manages the flow of stormwater from significant rainfall events to protect people from property from flooding. Just a few of the benefits of this type of design is it cleans and cools the air and water, enhances neighborhood livability, increases community and property values, enhances pedestrian and bicycle access and safety because it can be used in conjunction with creating crosswalks on busy streets such as Indian Head Highway. protects surface and groundwater resources, adds urban green space and even wildlife habitat, and it helps meet overall watershed management objectives. And on the left is an example of a grass channel with a bioswale that's treating all the street runoff. And you can see the street is kind of on the right-hand side of that left picture, and then the grass channel and bioswale, and then the sidewalk is on the left side. And then on the right side is a bioretention area that was constructed at the intersection of a street, again, between the street and the sidewalk. On the left, these are rain gardens that were constructed between the street and the sidewalk. And the water from the streets flows off into those areas and is filtered and then released slowly. On the right is just another example of a bioswale that's got more hardscape in it, such as rocks and things to make it look a little bit different than just having all the vegetation. In summary, stormwater can't be ignored. It doesn't go away. Obviously, we want the most value out of what we build, and multifunctional stormwater systems save money and land. We need to provide properly designed BMPs and low-impact designs to manage the impacts of stormwater downstream. And obviously, there's a liability associated with unmitigated downstream impacts, such as flooding is probably the most obvious. So what can you do? There's a few activities that every homeowner could become involved in to help manage stormwater. First is to limit the amount of impervious surfaces in your landscape. Use permeable surfaces where you can that will allow the water to soak in the ground. If you do have impervious surfaces, direct that flow to vegetated areas where it'll have a chance to filter and soak into the ground. And if you have any streams or waterways on your property, allow a vegetated buffer strip to grow along there so that it will filter the runoff and also slow it down before it enters the waterway. And plant trees and shrubs and different types of ground cover instead of a lawn, because they absorb up to 14 times more rainwater and they don't require fertilizer. You can install rain barrels to capture stormwater runoff to reuse to water your garden or water your flowers. And then there's some activities that will reduce fertilizer, pesticide, and sediment runoff from your property. There are natural alternatives to chemical pesticides and fertilizers that you can use. You can have your soil tested to determine the appropriate amount of the pesticide and fertilizer needed. And reseed bare spots in your lawn to prevent erosion of those areas.
We, as we get along in our project work that has an educational unit to it, we will be having additional briefings at our future town meetings.
Thank you, Doug, for a great briefing on stormwater management, something addressed to the layperson rather than to the technical workforce. We are incorporating at least two of those features in our new Trailhead Plaza. We are using pervious pavers. It's a paver with an enlarged joint between the pavers, so there's more room for the water to infiltrate down between the pavers into the ground. And we're also installing a rain garden at the front of the plaza where it meets the sidewalk, so that water from the sidewalk can drain into the rain garden, and water from the plaza that doesn't infiltrate between the pavers can drain off into the rain garden and then infiltrate into the ground. So these are all a newer set of site design features that the state of Maryland has adopted in their MD, Maryland Department of the Environment, Stormwater Management regulations. And all new development, all new construction is required to implement those features, and retrofit or renovation projects are encouraged to implement them to the extent that they can. So thank you again, Doug, for bringing that to us tonight. We have no presentations or resolutions. We do have one ordinance tonight. Ordinance number 06-01-14, an ordinance concerning removal and disposal of animal waste. It's on the agenda tonight for adoption. We introduced it at the June meeting. It will be adopted tonight. Again, this is another element from our Maryland Sustainable Maryland program that we're engaged in. This again addresses one of the areas of sustainability in the program. This one dealing with managing pet waste. We have implemented a leash law in the past, but now we're supplementing that with removal and disposal of animal waste. So
Before we get on with that, I'd like to have Nita Billard stand up. Nita is a member of our green team that did all the research on this and did the legwork necessary to have it done. I wanted her to be here tonight for the implementation of her effort.
Annie, would you read the ordinance, please?
Ordinance number 06-01-14, introduced by Mayor and Council. Date introduced June 2nd, 2014. Date adopted July 7th, 2014. Date effective July 28th, 2014. An ordinance concerning removal and disposal of animal waste for the purpose of revising requirements for the removal and disposal of animal waste and all matters generally related thereto, by repealing and reenacting with amendments Chapter 74, Health and Sanitation, Article 3, Litter, Section 74-24, Code of the Town of Indian Head, 1990 edition as amended. Section 1, be it enacted by the Council of the Town of Indian Head that Section 74-24 of the Code of the Town of Indian Head, 1990 edition as amended, Chapter 74, Health and Sanitation, Article 3, Litter, is repealed and reenacted with amendments to read as follows. Chapter 74, Health and Sanitation, Article 3, Litter, 74-24, Removal of Animal Waste. It shall be the duty of the owner of any animal to remove such animal's feces from the properties of others. An owner or person